Welcome to the first video in a series of 4 on inverse trigonometric functions. In this video, we'll discuss the main two inverse trigonometric functions, inverse sine and inverse cosine. Before we can even get to what those are, we need to discuss what's meant in this video by the word between. Between seems like a pretty clear word and might not need a definition. But in a minute, you'll see why I'm making the distinction about different definitions of this word. Suppose we were asked the question, is 17 pi over 6 between pi over 2 and pi? Let's imagine what that looks like on the unit circle. Here's the unit circle. You'll recall a circle whose radius is 1, centered at the origin. And you'll recall that pi over 2 is an arc length that terminates right here. You'll also recall that pi terminates here. So now to answer the question, does 17 pi over 6 lie between them? Let's think about where 17 pi over 6 would be. Because 17 pi over 6 is bigger than 2 pi, it would wrap all the way around and continue past one full revolution to right here. And by the way, this is coterminal with 5 pi over 6. So now to answer the question, is 17 pi over 6 between pi over 2 and pi? This question here does seem to have an answer of yes. Now, in some physical geometric sense, I guess you could suppose that 17 pi over 6 is between the other two, in a physical world kind of thing. The answer to this question, at least for the purposes of this video, turns out to be no. Reason? When we ask questions or make statements about is a certain number between two others, we don't mean does it physically appear to be between them on the unit circle. We mean literally, is that number between the other two in the classic numerical sense of between. Now what I've done here is I've converted 17 pi over 6, pi over 2, and pi into decimal approximations. And I think we can all agree that 8.9 is not between 1.57 and 3.14, despite the appearance on the unit circle. So in this video, when we use the word between, we don't mean physically, we mean numerically. So with that in mind, let's look at an actual example. We'll start with inverse cosine. Here's the definition. I'll give you a second to read that. Mathematical definitions, while accurate, can be a little confusing, so I always like to rewrite definitions in a more functional manner that gives the student, you, a step-by-step process on how to go about finding something. These two definitions are actually the same, as different as they sound. I'll pause while you read the second one. So here's our first example of an inverse trigonometric function. We're going to find the inverse cosine of radical 2 over 2. The first thing I need to mention about the negative one that you see in the inverse cosine, it is by no means an exponent whatsoever. And so just think of it as a reversal symbol and not an exponent of negative 1. Right, that being said, let's examine our unit circle and see if we can follow the three-step procedure above to find the inverse cosine of this value. Step 1, we need to find lots of solutions to cosine of blank equals the argument we're looking for, in this case radical 2 over 2. So to solve cosine of blank equals radical 2 over 2, that means we need to think of the question mark or the blank as an arc, which terminates at a point whose x-coordinate is radical 2 over 2. After all, the cosine is the x-coordinate of the terminal point of the arc. So, looking at our x-axis, here is approximately where radical 2 over 2 is. You'll recall from your study of the unit circle that radical 2 over 2 is approximately 0.71. Now, there are 2 points on the unit circle whose x-coordinate is radical 2 over 2. And so, we really have to look at these 2 points to find lots of solutions to the cosine equals radical 2 over 2. Here's one of them, 7 pi over 4. You'll recall from your study of the unit circle that the cosine of 7 pi over 4 is radical 2 over 2. That's just one example. You'll notice on step 1 it says find lots of solutions to this equation. Well, there's one of them. Another one would be a negative angle going clockwise. We can see that negative pi over 4 terminates at this point. This point has an x-coordinate of radical 2 over 2, and therefore the cosine of negative pi over 4 is that same value as well. But I don't know that we've found lots of them yet, so let's find another one. Here's another arc. This one terminates at pi over 4, and because that has the same x-coordinate, we can say that the cosine of that value is also radical 2 over 2. Now, step 1 is a little ambiguous about what we mean by lots. You need to keep finding solutions to that equation until you've met the criteria of step 2. So you really want to be looking ahead at step 2 so you don't end up finding too many or too few solutions to 1. As a matter of fact, really step 1 and 2 are kind of the same. You need to consider lots of solutions to this equation, but you really only need one that matches criterion 2, meaning the value of the arc length is between 0 and pi. So now let's move on to step 2. Only one of these will be between 0 and 2 pi. Look at the lower left corner of the screen, and you'll realize that only one of these, meaning pi over 4, is between the numbers of 0 and pi. And once you've found that unique one, then that's the answer to this question. And since we've found a value of an arc length whose cosine is radical 2 over 2, then that arc length, in this case pi over 4, is the solution to the inverse cosine of radical 2 over 2. Now let's look at an example of inverse sine. Here's the definition of inverse sine. It's similar but varies to a small degree, and we'll see that in a minute. And again, I like to give a more functional definition that allows you to follow steps to find a value rather than just rely on the meaning of something. So I think this how-to definition will be kind of handy. Here's our first example. Suppose we're trying to find the inverse sine of negative 1/2. I want to remind you again that the negative 1 is not an exponent, it's not a reciprocal. Many students think that the inverse sine is the same as the cosecant. You may recall that the cosecant and the sine are reciprocal functions. You may also recall from algebra that a negative 1 power is a reciprocal. So people get these mixed up. But again, I can't emphasize enough, the minus 1 is not an exponent in any way whatsoever. So let's look at our unit circle and follow our 3-step process for finding the inverse sine of negative 1/2. Step 1, we need to find lots of solutions to sine of something equals negative 1/2. For the sine of some value to equal negative 1/2, that value must correspond to an arc that terminates at some place whose y-coordinate is negative 1/2. You'll recall from the unit circle that the sine is the y-coordinate of the terminal point. So, looking at our y-axis, here is negative 1/2. There are only 2 points on the unit circle that have a y-coordinate of negative 1/2. So in step 1, these lots of solutions, any one of them would have to terminate at either of these points. So we'll try a mixture here. First, there's this arc. You'll recall that 11 pi over 6 is almost a full revolution. And you'll also recall from your study of the unit circle that the sine of 11 pi over 6 is negative half. So this is just one of the lots of solutions in step 1. Here's another arc, 7 pi over 6. You'll also recall that the sine of that is also negative 1/2, hence another solution. Let's find one more. Here's a negative arc in the sense that it goes clockwise, and it terminates at a point whose y-coordinate is negative half, and therefore the sine of that is also negative half. Now, step 1 is a little ambiguous because it says lots, and in the last 2 examples I've found 3. But there's no exact number that you have to find. You just have to at least find one that matches criteria number 2. I've found 3 of them here, just to give you a general sense of the process. You may find it on your first guess. To know your guess was right for step 1, when, according to step 2, you found a value between negative pi over 2 and pi over 2. Looking at the left corner of your screen, out of the 3 arc lengths that we've found, all of which have a sine value of negative 1/2, only one of them, negative pi over 6, is between negative pi over 2 and pi over 2. And therefore, that is the answer to this question, negative pi over 6. Well, now that we've seen an example of both inverse cosine and inverse sine, it may be a good time to summarize and clear up any confusion, because it can be a little strange hearing this, especially for the first time. So let's re-examine the 2 problems we've seen today. In both cases, the inverse trigonometric function is looking for an arc length whose trigonometric value is that argument. And now, it really just comes down to guess and check. That's the very bad news about inverse trigonometric functions for some students. You essentially have to keep guessing what would go into these blank parentheses here until you get something that meets all the rules of inverse cosine or inverse sine. For inverse cosine, you must find something between 0 and pi. That was in the definition that we saw earlier. For inverse sine, you must fill in the blank with something between negative pi over 2 and pi over 2. The reason why the definitions are different is very interesting and very profound and very off the point, actually, of trying to find these, so I will leave that for a future video. In the meanwhile, let's go about following the rules that the mathematicians have wisely chosen. We'll start with the inverse cosine problem. Now, you've already seen it, but let me summarize the concept of what happens here. We need to fill in the blank in the bottom left corner here. The cosine of something equals that value. Now, you need a very detailed knowledge of the unit circle, because you need to keep finding values to fill in that blank until one of them just happens to be between 0 and pi. For example, the cosine of 7 pi over 4 is radical 2 over 2. However, 7 pi over 4, that's bigger than pi, so that can't be it. The cosine of negative pi over 4 is also radical 2 over 2, but that's lower than 0, so that can't be it. And eventually, just through your knowledge of the unit circle and a little bit of luck, you'll stumble across the fact that the cosine of pi over 4 is also radical 2 over 2, but pi over 4, or 1/4 of pi, is in fact between 0 and pi, and therefore pi over 4 is the value of that inverse trigonometric function. Let's again review how we found inverse sine of negative half. We need to fill in the blank in the lower right corner so that that's a true statement. But we must also find something between negative pi over 2 and pi over 2 by the very definition of inverse sine. Now it turns out, through your knowledge of the unit circle, you should know that the sine of 11 pi over 6 is negative 1/2. Now 11 pi over 6 is not between negative pi over 2 and pi over 2. Therefore, that can't be the answer. The sine of 7 pi over 6 is also negative half, but that also can't be the answer because 7 pi over 6 is bigger than pi over 2. Eventually, through your knowledge of the unit circle and a little bit of luck, you'll stumble across negative pi over 6. The sine of negative pi over 6 is also negative 1/2, and it is a value between negative pi over 2 and pi over 2. And so, one has to approach inverse trigonometric functions with the spirit of guess and check, because there's no actual procedure, short of using an app, there's no actual procedure to find them. And therefore, that answer to this question is negative pi over 6. And that completes this first video in a series of 4.